Good evening, class. This is Lesson 19, Friendly Chemistry, Writing Empirical Formulas. So, writing empirical formulas falls under a subcategory of quantitative analysis, which is how to understand and identify unknown chemical compounds that are oftentimes byproducts of the laboratory. And the good thing with compounds is their ratio stays the same. I'm on page S166, and the empirical formula is just the formula with the most reduced whole number ratio of ingredients in a compound. Like, for example, right here, the 1-to-1 ratio on this page for sodium chloride, right here. All of the elements or compounds on our master list of ions are empirical formulas. Again, so it's the chemical formula in which the compound is the most reduced. It's a whole number ratio, and that is the empirical formula. So they have you do some things down here on the bottom of S166 that we're going to go over. So they have H2O. I just wrote them over here. Now, in H2O, you can divide that by 2, but as you can see, you're dividing a 1 into 2, which is going to equal a half, which is going to leave it as not a whole number. So your H2O with the 2 and the 1 is going to check to be the empirical formula or the lowest reduced one. The next one is H4O2. Well, you can divide 2 by 2 to get 1. You can divide 4 by 2 to get 2. You end up with H2O, and you've got your empirical formula. The next is the potassium phosphate. You've got the K3, the PO4, 1. You can divide the 1 by 3, but you know that's not going to give you a whole number. So your K3PO4, 1 is your empirical formula for potassium phosphate. But they gave you another potassium phosphate. Here it is. They gave you K6PO4, 2. You can divide the 2 by 2 to get you 1. The 6 divided by 2 gives you 3. It brings you to K3PO4, which brings you to the empirical formula. So see, we did divide, and we were able to get whole numbers with that. The last one is your chromium nitrite. Your chromium nitrite is a 1 and a 3. Again, if you're trying to divide a 1 by a number, you are not going to end up with a whole number. The lowest whole number is 1. So you pretty much know that that is going to be your empirical formula for your chromium nitrate. Okay, so now we're going to move on to page 51. No, it's 51 in my book. It's S167 in your book. And we're going to talk about how to identify and calculate from these analysis, these compounds that we get, this compound analysis, in order to get our empirical formula. And there's two things that we need to make sure we do first. The first thing is to assume 100 grams of the compound. Assume you have 100 grams of it. That makes it the math a lot easier. And the next thing is you find the number of moles in each ingredient. So your example on page S167 is you have a byproduct of 20% calcium and 80% bromine. So you take your 20%, you multiply that by 100 because you assume 100 grams, and it gives you 20. The reason it gives you 20, if you recall, is that 20% equals 0.20. When you multiply something by 100, you're simply moving the decimal place back 2 spaces. 1, 2. I'm sorry, I'm going the wrong way. 1, 2. And it'll leave you 20. So if you start at 0.2, bloop, bloop, it leaves you 20. So that's why they do 100 grams, because it makes it easier. So then you have your 80% of your bromine. You multiply that by 100, and you end up with 80 grams. So yeah, you have your 20 grams and your 80 grams. Step 1 is completed. Then they want you to find the atomic mass. and make a ratio. That's how we convert it into moles. So your 40 grams that you decided you had of calcium is to 1 mole, this is your ratio, as 20 grams is to X moles. You set that up like an algebra equation. 40 over 1 equals 20 over X. Here's your 20 over X. You cross multiply, which means you multiply the 40 times the X and put it on one side, and the 1 times the 20 on the other side. Then you want to get the X by itself, so you divide by 40 to get it off this side. You divide 20 by 40, and then X equals 0.5, because 20 is half of 40. That's for your calcium. The next is your bromine. You have 80 grams of bromine is to 1 mole, because on the periodic table it tells us that a mole of bromine is 80 grams, as we have 80 grams of bromine is to how many moles? Well, we know it's 1 because it's on the periodic table, but if we wanted to do the math, it would be 80 over 1 equals 80 over X, there's your X, cross multiply 80X equals 1 times 80 divided by 80. 80 divided by 80 is 1. X would equal 1. So we've converted it now to moles. We're almost done. Then we take, but what it leaves us with, the formula it leaves us with, is not quite the empirical formula, because our calcium is only 0.5 moles and our bromine is 1 mole. Remember, it said we needed a whole number here. So to convert it to a whole number, we divide both sides by the smaller number. You're going to be doing a lot of this. So you take your 0.5, you divide it by 0.5, you take your 1, you divide that by 0.5, put it on a calculator. You don't have to know this by heart. You end up with 0.5 divided by 0.5 is 1. 1 divided by 0.5 is 2. You end up with Ca1, Br2, and if you look on your periodic table, you can check it, because calcium is a +2 and bromine is a -1, and you balance. If you're balanced and you check, you have achieved the empirical formula. Now, starting on page S171, they set up another problem for you. Go ahead and work through that. They work through it very, very detailed in the book. Let me know if you have any problems with it. And that gives you lots more practice in the practices. We will see you Monday. Let me know if you have any questions. Have a good week.